Hello everybody. In this video we'll be covering one of the sections in chapter 4 of our textbook entitled Atoms and Elements. In this video we'll be covering charge on an atom or molecule and ions. So we'll start talking about what is a charged atom. Okay, so we now know that the number of protons determines which element we have. For instance, all sodium atoms have 11 protons in the nucleus. In a chemical change, the number of protons in the nucleus of the atom doesn't change. Okay, this would be called like transmutation, which goes all the way back to like turning lead into gold and stuff. And we know that that doesn't happen unless like there's some sort of emission or absorption of radioactivity or a nuclear reaction has happened. Atoms in a compound are often electrically charged though, and we call these ions. And the reason that we get charge is through the gaining or losing of electrons. Okay, so the protons stay the same, but we can either gain an electron or lose an electron. The charge is going to be the number of protons minus the number of electrons. Okay, so if we look at this equation here, protons are positively charged. It has an inherent positive value in front of it, and the electrons have that negative there. So if I have more protons than electrons, I'm going to have a positive ion charge. If I have more electrons than protons, I'm going to get a negative charge. So the ions that have that positive charge are called cations. And I always remember this because cats are inherently positive things. So this is the case where we have more protons than electrons, okay? And that occurs by losing electrons. Ions with a negative charge are called anions, which I remember as not the cations. And that's where we have more electrons than protons. So this term is larger, giving us a net negative charge. And this is going to be formed when we gain electrons. Chemically, ions are much different than neutral atoms, okay? Because they have a different structure. The charge is going to cause molecules to change their structure, and they start to have the interactions that we would associate with charge. So nonmetals form anions. So we're talking about the types of elements that are on the right-hand side of the periodic table. For each negative charge, the ion has one more electron than the neutral atom. So for instance, neutral fluorine has 9 protons and 9 electrons, but an F minus is going to have 9 protons, which is the same, and an additional electron, 10 electrons. Phosphorus, as a neutral species, is going to have 15 protons and 15 electrons. When it forms a P3 minus, it's going to have 3 more electrons. Do note that we note the charge of an ion by putting a superscripted value up here, and we put a number and then a sign next to it. So this would be like phosphorus -3 ion of phosphorus. And that when we don't have a number there, we assume that to be a 1. The anions are named by changing the ending of the name to "ide." Okay, so fluorine becomes the fluoride ion. Oxygen becomes the oxide ion. The charge on an anion can often be determined from the group number on the periodic table. Okay, so everything in group 17, or halogens, is going to have a negative 1 charge. Everything in group 16 is going to have a -2 charge, and we'll get into that a little bit more in a minute. So our metals tend to form cations, so they're going to be positively charged. For each positive charge, the ion has 1 less electron than the neutral atom. Okay, so similarly, sodium is going to lose an electron to form a Na plus ion. Calcium is going to lose 2 electrons to form the calcium 2 plus ion. Cations are named the same as the metal. All right, so sodium becomes the sodium ion. We don't change the prefix or suffix, and we do add the word ion there. We have the calcium ion. The charge on a cation can often be determined from the group on the periodic table still. So group 1 is going to tend to form a 1 plus. Group 2 is going to tend to form a 2 plus. Aluminum, gallium, indium is going to be 3 plus. You'll note that as you go down that group, the reason that we're making these specific is that once you get to indium, you start to get into the metalloids. It's got that step down thing on the periodic table, so things get a little murky further down that group. But these 3 in that group, the top 3, you're going to tend to see a 3 plus. Okay, so let's try a problem here. We're going to find the number of protons and electrons in a calcium 2 plus. All right, so we're given just a formula here, calcium. We know that it has a 2 plus charge. We're asked how many protons, how many electrons, how many neutrons does it have? We know that the ion charge is going to be the number of protons minus the number of electrons. And our basic solution map here is we're going to start with a symbol. That's going to go to the atomic number, which is the number of protons, remember. And then we're going to be able to deduce the number of electrons from the ionic charge using this formula here. So Z, the atomic number, is 20, which is going to be the number of protons. We got that just from looking on the periodic table. We looked up calcium. We know that the ionic charge is going to be equal to the number of protons minus the number of electrons. We now know the ionic charge is 2 plus. We know that the number of protons is 20. Okay, we can plug that into the equation and we can see that the number of electrons is 18, which is 2 less than 20, right? So give us that 2 plus charge. And we know that the cations for cations, protons is greater than electrons, so our answer is reasonable. So now I want to give you guys the opportunity to do a little practice. I've given you several symbols for ions here. I'd like for you to look them up in the periodic table, look up their atomic number. You can figure out how many protons they have, and then based on their charges, you should be able to determine how many electrons they have. I'll give you guys a moment to do that. So we can see here that when we have a -1 charge, we have 1 extra electron. When we have a negative or a +1 charge, we have 1 fewer electron, and that pattern holds when we now have 2. We have 2 more electrons, 2 fewer electrons. And these values we would have looked up at the periodic table that would have been specific to the elements we're talking about. So let's talk a little bit, this is kind of a precursor to some content that we're going to have later. Which electrons are moving in this situation? So we have this thing called the valence electrons, okay? These are the highest energy electrons in an atom, okay? And we'll see later that there's actually a correlation between how much energy these electrons have and how far away they possibly could be found from the nucleus. So these ones have the greatest probability of being furthest away from the nucleus. That's the energy, the potential energy that they have that allows them to be the ones that are going to be picked off, or that's the spot where they're also going to be added to. Metals form cations by losing their valence electrons to get the same number of electrons as the previous noble gas. Okay, so let's see what that means. So if you think of lithium, right, it's going to have 2 electrons after, so it's got 3 electrons as a neutral species. It's going to form a lithium +1 ion. After that, it's going to have 2 electrons, which makes it what we would call isoelectronic with helium. So helium as a neutral species has 2 electrons. Similarly, if we look at aluminum here, right, it's going to lose 3 electrons to have a total of 10 electrons, which is the same number of electrons as neon. And we know that helium and neon, being the noble gases, are very inert. They don't like to react, and that's due actually to the stability of their electronic configurations. Okay, so this is a very stable condition to be isoelectronic to one of the noble gases, and that's why they do it. Nonmetals form anions by gaining electrons to have the same number of electrons as the next noble gas. So we're just going the opposite direction, right? When chlorine picks up an extra electron, it has 18 electrons, and that makes it isoelectronic with argon. And when selenium picks up 2 electrons, it's going to have 36, which makes it isoelectronic with krypton. So you can think that chlorine would have to lose 7 electrons to get to be isoelectronic with one of the noble gases, right? And that would put a +7 charge on it. So it's not difficult to see why gaining a single electron is preferable to losing 7 electrons, right? Because then you're going to have quite a bit of charge there. That's going to lead to a lot of forces between chlorine and other atoms. It's going to minimize its charge that it has to take on in order to still be isoelectronic with one of the noble gases. The charge on an ion can often be determined from the element's position on the periodic table. We've alluded to this. Metals are always positive ions. Nonmetals are always negative ions. For many main group metals, the cation's charge is equal to the group number. For nonmetals, the anion charge is equal to the group number -8. So let's think about, let me show you a picture of what that actually winds up looking like. So for group 1, we see all positive charges. For group 2, we see all positive +2 charges. Over here at group 7, we get 7 minus 8, -1 charges, -2 charges, -3 charges. Here we see +3 charges. And here would really be the splitting point, right? They can either gain 4 electrons or lose 4 electrons. So things get a little bit murkier here. You do see some charges in this group sometimes with some chemistry, but it's not as common of a thing. And we have this big block here that's not filled out, and we have this big block down here that's not filled out, and even some of these heavier ones down here we have not filled out. And the reason for that is these guys can take on different numbers of charges. Okay, they actually have some interesting electronics that's happening that allows them to sometimes be 2+, 3+, 4+, so on and so forth. So we actually have to use contacts in order to be able to determine what the charge on one of those is. So basically, if you see it bound to, say, an oxygen, bound to a copper, and the overall thing is neutral, you know that that copper has to be 2+ to balance the 2- oxygen. And we'll be talking a little bit more about that in some later chapters, but that's just a little bit of a precursor to what we're going to be doing.